Hello, everybody, and welcome to MetalCon Live. I'm Kaylin, the Trade Show and Event Specialist for MetalCon. Today's session is being presented by the MCA's IMP Alliance. The course is Bidding and Estimating Insulated Metal Panels, and our speaker today is R.C. Antle from ATAS International. The MCA is a fantastic association to join if you work in the metal construction industry. Not only do members get special pricing from MetalCon booths, you also get additional benefits and access to biannual meetings, sharing the latest and greatest in the metal construction industry and things coming down the pike that you should be aware of. Additional information on how to become a member is listed here on the screen. Mark your calendars for August 16th, our next MetalCon Live, which is Decoding the Language of Rain Screens. That course is being presented by Andrew Ashton of RAINA. Registration is now open for MetalCon, and be sure to register now. Early bird pricing ends in 48 hours, so register as early as you can to save as much money as you can. Also very excited to announce that the MCA's IMP Alliance is presenting a session at this year's MetalCon, Designing Outside the Box. It will be featured in the Architects Experience. So architects listening here, mark your calendars for that very special presentation at MetalCon in October. Finally, if you run into any technical issues or have any questions, please feel free to message in the chat. If you run into the technical issues, I'll be happy to help you in any way that I can. Just message me directly at MetalCon Live, and I'll be there to assist. For continuing education credits, please fill in the brief form that pops up on your screen immediately after the session ends. Filling in that form helps us put in your full name, your AIA number, and all other pertinent information. If you are an AIA member, it also ensures that we get you an appropriate certificate for this course. Without further ado, I'm going to hand this over to RC. RC?
All right, perfect. Thank you so much for the introduction. And I believe, there we go. Okay, perfect. Thank you so much. My name is R.C. Antle with ATAS International. I'm the Director of Insulated Metal Panels at ATAS, and ATAS is located in Allentown, Pennsylvania. Now, a little bit about the IMP Alliance. The IMP Alliance consists of manufacturers, suppliers, and resellers who pay membership to be part of the group. And the Alliance formed to increase the use of insulated metal panels in the building envelope by supporting product performance testing, initiating research, and through marketing, education, and and public policies that affect the use of growth of IMPs throughout the marketplace. And our presentation today will be bidding and estimating with insulated metal panels. All right, so let's get started. So estimating basics. With every type of insulated metal panel project, there's obviously things that we really have to look at, and that will make them much different than other types of metal construction. And that's today's purpose of the presentation. Now, before we get started, let's take a look at what insulated metal panels are. So insulated metal panels consist of an exterior facer skin, an interior liner skin, and that's sandwiched together with a polyiso-cyanurate foam core. These are complete wall assemblies. Now, you'll still need building framing, but the panels will act as the finished exterior. They'll act as the vapor and air barrier. They'll act as the thermal performance. And then when left exposed on the inside of the building, they are a finished interior liner of the panel. So they are an absolute barrier, a complete wall assembly there. And like I said, the outstanding thermal efficiencies and speed of installation really make them beneficial in today's high-performing building projects. There's a wide variety of profiles, different textures, colors, and embossing textures that are available. Really, the panels are limitless in their application. They can be used in cold storage facilities, commercial and industrial and architectural facilities, also used as roof systems, and then also, last but not least, barrier backup systems. So they really can meet a wide variety of applications. Now, a little bit of video about IMPs.
Composed of 2 sheets of cold rolled galvanized steel and an advanced polyurethane foam core, IMPs provide a pre-manufactured perfect wall. This metal and foam composite construction creates a rigid panel far stronger than the individual parts.
So in summary, insulated metal panels are that complete all-in-one wall system with the exterior finished, the vapor and air barriers built in, the thermal performance, and then also those finished liners for the inside of the building. Now, when we get into the estimating basics of it, there's a variety of drawings that we want. This is very important. And those include our plan views, our floor and roof plans, which are very important, elevations, which really give us the design intent of the building, as well as measurements, penetrations, different garage doors, man doors, and so on. Our roof section and wall sections there, so we can see a cut through of the building. And then also the details where we really drive down into attachment methods and other special considerations. So at a minimum, these are what we are looking at when we are starting to do a takeoff with insulated metal panels. Now with the elevations, the first we want to look at is the elevations. And they're very helpful for a variety of items. First, we get the size and scope of the building. We have a general understanding of the design of the building, the architectural features of it, how cut up the building is. Is there a lot of windows? Is there windows in it? Is there doors or there garage doors or other types of penetrations in the building? We can also see the slope of the building, the height, and the overall length of the building. We can also see other considerations. Is there other architectural details such as eyebrows on the building or special sill considerations with it? When we first look at the elevations there, we're going to look at the width of the building and understand, okay, start laying out our panel layouts there. We can also see height. And these are things that we're taking into consideration, not only from a material standpoint, but also from a labor standpoint. So this is really going to give us, the meat of the project to see how much materials we're really going to need. Also, we can see from the elevations, is there any bump outs or is there any jogs on the building? If there's some sidewalls there, we will need to take that into consideration with insulated metal panels, because panels, come in a variety of widths, most commonly 30, 36, and 42, with 42-inch being the most common. There's little room for error there. So if we miss a sidewall, there could be, a lot of square footage that we're leaving off. So once again, with those elevations, we're seeing that width and the height of the building and the type of penetration. So we have to account for all of our trim details there, head details or jam details or sill details, along with garage doors. And we can also look at areas of potential deduction where we can maybe eliminate some panels. Now let's take a closer look at that. So here's an elevation where we can see that looks like there's some windows or there's some louvers. We can see that there's a man door on the elevation. And then we can also see some large garage door. Now, another thing about the elevation is, we can see other materials. A lot of times insulated metal panels are incorporated with other products, maybe some CMU or some brick. And that appears to be like that on this elevation. So that's a consideration. We can take the width of the building to see the overall length of it. Looking at our insulated metal panel, say being 42 inches wide, we can determine how many panels were needed. We can also look at the height of the building here, and then we can start doing our takeoff for the trim conditions. So we're going to have to account not necessarily for that man door there, but certainly the large garage doors and also those windows or louvering areas. Also, if it's an insulated roof, we're going to be looking at, for example, the rake detail here, and also the eave, and also any gutter type conditions that we might have on the building. When we get into our floor and roof plans, once again, we can compare this to the elevations to ensure that everything is scaling correctly and that we have the correct width of building and length of building. Now, if you pay particular attention down in the lower left-hand corner of the screen there, we can see that there's some jogs on the building. And that's very important because we need to account for that. If we were just to take the length and width of the building, the face of the building, if you would, if we miss those jogs, we would really be shorting ourselves on panels and also trims. And that's very important that we do account for those because, when you're looking at overall material costs and when you're putting together an entire package, if you're short a couple hundred square feet, that really can make a difference on your bid. And you want to account for that while you're doing it. When you get into your wall sections, this really looks at, we can get into the details of maybe roof to wall connections. We can see there down in the lower right-hand corner if there's a curb, maybe that the IMPs are sitting on. We can look at any other type of penetrations, and we can start getting into our connection points. And often we'll see, framing or attachment methods. So we can start accounting for maybe some customized trims or requirements. Another thing is that we can look at panel thickness. A lot of times we can scale, if it's not labeled on the building, the panel thickness, say for walls or roofs, if that's not in the specification or listed somewhere else in the drawings, we typically can pull that from the wall section here. So it really gives us a cut through of the building and an understanding of the purpose and the connection points, especially with that wall to roof. Also with the details. Now, while most buildings, this is not absolutely required, but the details are very helpful because we can understand the architect's intent as far as attachment method, ceiling methods, is there back fastening or any other special type of requirements? And then also we can see, framing attachment to it. So we really get into, the accessory side of it, which is very critical with insulated metal panels. We want to account for all the proper sealants, the clips associated with it, the type of fasteners that we would need for the entire estimate. When we're putting these together as a manufacturer, we're looking to encompass the entire building, the panels, the trims, the accessories, any other special details or requirements that would be needed. While not always readily available, renderings, when they are available, are very helpful. The reason for it is we can really see the picture in real life, the building, what the architect's true design intent here. Often we can see, potential colors that the architect is looking for. We can see if there's other materials such as like CMU or brick or other metal products in the building. We can also see if there's, say, some eyebrow details or custom banding that may be metal. We'll want to pick those up. And then we can also get a better understanding about the details, the windows, the doors on the building, if there's any type of special fascia or coping requirements there, possibly colors. So really gives us an overview and understanding of what the architect's true intent is. I find these very helpful when we're reviewing a project. Now that we have a basic understanding of the types of drawings that we're looking for, say floor and roof plans, the elevations, the wall sections, and of course the important detail areas, how do we actually do the takeoff when we're getting into it with insulated metal panels? Well, first and foremost, with insulated metal panels, we want to look at that weathering area. If the wall is 10,000 square feet, at an absolute minimum, you're going to need 10,000 square feet of panels. And it is actually more. We're going to show you how to account for that when you're doing your estimating or takeoff. We also want to account for any type of scrap. With insulated metal panel, just like any job, there is going to be some scrap or some field loss when installing the material, especially when we get into roof panels. There's laps and also eave cutbacks that we have to account for, and they're often missed, and that's very important that we account for that additional square footage. And also there's areas where we can deduct when we get into, say, large garage doors, where we can save a little bit of square footage and a little bit of materials, but we have to do so carefully. So these are the three areas that we're going to look at, and this really gets into where we're really starting to do the takeoff. Now, when we look at the elevation here, this is a small area that we're showing. We see a couple things here. We can see the length of the building. We can see the highest point of the building. We can see the slope of the building. We can also see any type of penetration, such as windows or louvers or doors. And if you were just to take this and just measure the total square footage, you're really going to be shorting yourself when you're doing the takeoff. So what we have to do is we have to visualize and remember the width of the panels. So for example, let's think of a 42-inch wide panel. And when we're doing takeoffs, this is really what we need to account for. A lot of times on a elevation, a 42-inch wide panel might not work across the entire structure. So that first panel on, say, the left part of the elevation to the right part, that first and last panel might have to be cut down to fit so the building's even and symmetrical. And you can see that here on this example. We can see that left panel is a little different width. And then we have our modules, whatever they may be, 30, 36, 42. And we can start doing that panel layout. And you can see that last panel there actually goes over the corner of the building. And that needs to be counted for, because if you just went by the weathered area on the building, you may be shorting yourself. So here we're actually accounting for full panel width and full panel layouts, even the areas where we're going to be cutting down and scrapping. You can also see, because of the roof slope here, the way the panels are stepped. We don't want to start a cut at the very small part of the corner. We want to give ourselves a little bit extra room if we do have to cut those panels down. And you can see at the roof slope there, the panels extend a little beyond the roof, and then there's room for the installer to go ahead and cut that material down. So this is a very important part. Another area is when you are looking at an elevation, let's say the building has a consistent height of, say, 25 foot, and the length of the building is 100 foot long. We could take that 100-foot width, divide it by the width of the panel, and let's say that magic number turns out to be 19.25 panels, where you're going to have to round up to 20 panels there. That way we ensure full coverage over the building. So that's another way to look at it. But visually, and when you're thinking about the estimating part of it, this is a good visual representation of what you need to account for. Now, when we get into the roof side of with insulated metal panels, there's two areas that we have to take an additional consideration. So, of course, we have to account for that roof slope of the building. That will make the panels longer. We also have to account for the run. So let's say from eave to eave, we're looking at, say, a 100-foot long building. We have a roof pitch of, say, a 112, and then the panel lengths might be, say, 53 foot. Well, we have to take into consideration, besides all that, any laps or eaves. Now, a lap cut is where we would have a panel, a roof run is 90 foot long. Well, most manufacturers can make panels up to, say, 53 foot. So we're going to have a lap joint there, where the top panel, and you can see that in the image, the underside of the panel will actually have to be cut and lapped onto the lower panel. And this is very similar to how single skin metal is accounted for. Also, another consideration is down at the eave there. The gutters with insulated metal panels in the eave trim are part of the top side facer panel along with the rib there, and they amount to that. So we have to account for an eave cutback as well. And if you're looking at, say, you have a lap cut of 6 inches and an eave cut of 3 inches, that's 9 inches, and let's say the overall length of the building is 300 feet. That's a lot of square footage that we do need to account for, especially not only from a bidding and estimating side, but from a ordering standpoint, where the panels may be short. Now let's take a closer look at that. I had talked about the lap cut, and you can see that we have a panel here and we have a connection. Well, that area highlighted in blue is typically a 6 to 8 inch eave cutback, where that panel, the liner side metal and the foam is actually removed, only leaving the facer side metal skin. That is going to lap that lower panel there. And there's sealants and fasteners that will make that weather tight, but we do have to account for that 6 to 8 inches depending on the manufacturer. Once again, this can add up to a lot of square footage, and we really do need to account for that. Also, at our eave locations, whether you have just an eave trim or you have a building that requires gutters, we have to account for that eave cutback as well. And very much like that lap cut, the panel comes down, and you can see that blue area, the panel would extend that far out. Each manufacturer is different, but typically, anywhere from 5 to 9 inches will need to be accounted for. And once again, on that roof panel there at the eave, that liner side piece of metal on the panel, also the foam will have to be removed, leaving the facer side skin along with the facer side rib there. Once that's removed, the eave trim can be put in place, and then the gutter can be attached to the panels, which attach to the ribs. So we have to have that 5 to 9 inches of overhang to account for any eave trim or any gutter that would obviously be on the outside of the material below, such as an insulated metal wall. Once again, on those connections, we want to ensure that we're accounting for that even lap cut that can really add to a lot of square footage. Now let's take a look at the roof quantity. So when we're doing estimates for these, when you're looking at a large roof, if you're doing, say, a quick estimate and you just kind of want to get a general scope of everything, I would add about a minimum of 5% between, loss, lapse, additional materials. It's very common when panels are in sight, they potentially get dented, dropped, a forklift runs into them. So you're going to want to account for additional materials. And on large projects, typically 5% will cover you. Now on smaller roofs, you would think, okay, smaller roof, not going to need as much material. Well, it's quite the opposite. When you have smaller projects, we often find additional trims, additional accessories are required, and that goes along with the roof panel itself as well. So a good general rule of thumb to allow for additions on a small roof is approximately 10%. That should cover you so you don't short yourself when doing the estimate. And once again, each project is different depending on the considerations and the complexity of the project. Is there multiple slopes? Is there any type of valleys on the building? That's very important. But once again, these are rough guidelines to help ensure that you're calculating the correct amount of material that you will need. Now, when we get back into the walls, we talked about that there's some areas that we can deduct. So when we looked at those elevations and we saw, say, any type of louver or man door or small window openings, what we would normally do with that is run those panels straight through. So we would run full-length panels, and the areas where those windows are, the small louvers or man doors, they would just be cut in the field, and that would just be scrap. That would be potentially used in another location, or it would just be scrap. Now, when we get to large openings, such as garage doors, those are areas that we can account for some deduction and save some additional material. Now, when we look at this elevation here, let's start on the left-hand side. So you can see a full-length panel, another full-length panel, but you can see that panel has actually been cut down, and that would be field cut by the contractor in the field. Then you can see above the garage door that there's 3 panels that are actually cut short. And those panels, you may or may not have to order them full length. You could potentially order them the length required to hit the head part of the garage. Then you can see on the right side of the door there, it's another full length panel that's been cut down, and then that continues in full length. Now, one thing that we want to be careful with is, depending on the drawings and the scale, also real life applications, windows or doors will move a little bit. And if we look at this example, let's say the person doing the estimating here, that first panel that's being cut, if that garage door moved over another couple inches, you might really need that full length panel and it may not be cut down. However, if the garage door moved left a little bit, you might have not need a full length panel. However, we can't always account for that and know exactly, because things change from what the actual drawings show to actual field requirements. So to account for this correctly, it would be very important to have a safe deduct. I'm never one to go for an aggressive deduct there. It's a cheap insurance policy to have a little extra material. Bottom line is about a 50% deduct. That is the correct way to do it. And for this example, instead of deducting those 3 panels at the top there, we would go with 2 panel deductions. So you could order 2 panels at the appropriate length, but that third panel, you would have that as a full length panel and then cut it in the field as necessary. So once again, to account for your large openings and large penetrations, a 50% deduct is relatively safe. Now, when we get into the components, now that we've looked at the materials and the items that we need to do the takeoff correctly, the areas that we want to look at as far as figure out panel quantity and trim counts and accessory counts. Areas that do add to the estimating are obviously the components. Now, when it comes to colors and finishes, those are all areas that add money. Typical colors would be like a 2-coat 1 mil PVDF, known as like a Kynar or Hylar paint finish. That's typically an industry standard that we see there. However, stainless steel or other metals or other finishes like a 3-coat paint system, marine grade paint finishes, they do all add to the cost of the panel. So you do want to account for that when you're doing your estimating. The gauges of the skins, most commonly is 26, 24, 22, and in some cases even 20 gauge. So if your specification calls for a 22 gauge metal facer with a 24 gauge liner, you're going to need to account for that because that does add dollars versus say like a 26 gauge. Another consideration is small quantities of materials. And what I mean by small quantities of materials, most manufacturers, I would say that sweet spot's around 5,000 square feet of material or higher. But when you get into small quantities like 500 square feet of material, there's a lot of setup and downtime for the manufacturer to do that change out, to run that small quantity. What complicates it even more is if, let's say it's a custom finish or a custom metal, that will add significant cost to the price of the panel. So, the quantities, you have to be aware of that when doing your estimating. Once again, special metals will add to the cost of the material and those gauges as well. And then when you get into different profiles, each manufacturer offers a variety of profiles, whether it's striated, pleated, fluted, and those panel profiles may add to the complexity and also the cost. Another aspect is panel widths. Not all panel widths are priced the same. For example, a 30-inch wide panel may have a higher price point than a 42-inch wide panel. So these are all considerations from once you have your material counts and you know what you need, that certain aspects, the textures, the colors, the finishes, the widths, these are all areas of consideration when doing your estimating. Now, there is an opportunity when needed, say a project is over budget and value engineering is required or at the direction of the building owner or architect. There's some options and areas to help control cost. And they're very dissimilar to what we were talking about, that add cost. It would be recommended if you were looking for a cost savings or to keep your budget low, would be to go with manufacturer standard colors. Anytime you get into a custom color or a multi-coat process, will add money. So keeping with standard colors will help control the budget. Keeping with standard gauges, for example, with a pleated profile, one of the most common gauges I see out there would be 26/26. So if it was, say, 24/26, by switching to a standard gauge, 26/26, may save additional money towards the budget. And then also panel profiles. If a building has, say, 3 different profiles and 2 of them are really small quantities, by simplifying and staying with the same profile or limiting the profiles and limiting the colors and also limiting the widths could help, keep the project in budget there. In manufacturing, we kind of have a little joke, with enough time and enough money, manufacturers can pretty much do anything. However, I've never seen a project that is way under budget and has unlimited resources to spend. So, knowing these areas, where to save, and also, sticking with standards will certainly help achieve the building owner what they're looking for, as well as the architect there. So these are all areas of consideration and cost savings. Another very important aspect is the labor. This is one of the biggest things. Now, with insulated metal panels, because of the speed of installation, you can really save a significant amount of money on the labor side of it. For example, with insulated metal panels, when you're running panels vertically on, say, a commercial or an industrial application, it's not uncommon for a contractor to be installed about 5,000 square feet of material per day. That's a lot of square footage and can really dry a building in rather quick. Now for architectural applications, say a horizontal panel with trimless ends and factory formed corners, that's going to take a little more labor, a little more skilled labor. That's going to take a little additional time. So your max might be around 1,100 square feet a day. So considerations, where the project is, the labor that's used for it, the complexity of the building. These are areas that add cost or areas that potentially can save cost in labor. Also specialized equipment that the labor may need to use. So once again, labor is a big savings with insulated metal panels because of the amount of material that can be installed, but definitely needs to be accounted for. Also, how complex the building is, the trim requirements, the detail requirements are all going to fall under the labor aspect with insulated metal panels. Another area is specialized equipment. If we have a building, say that has, rooftop monitors and they're 10-foot panels, you may need a crane to get it up to the roof. But as far as additional equipment to install into the building, you may not need additional equipment. However, most buildings, as shown in the pictures here, a lifting equipment is often required. Suction cup machines for the panel can be rented or purchased. Also, what type of lifts are required? Is there cranes involved? Is there moldable cranes? What type of man lifts are needed to install with the insulated metal panels? Also, another consideration is unloading the materials. When the materials arrive on site, typically by flatbed, do you have the proper lifts or forklifts to unload the material? And these are all areas that can really affect, the associated costs with your estimating. You really need to account for these things, prior to, not get on the job site and determine what type of equipment is needed. And once again, the labor to run this equipment, do you need, a crane operator to run those cranes? So these are all areas of consideration. Now, site conditions. We all know that image in the upper left there. Every job looks like that, or at least I wish it did. But realistically, most sites look like the one in the lower right-hand corner. And these really will affect the equipment you need and also the labor. You can see in the image in the upper left there, you can see that site's relatively wide open. The weather looks great. The site is very clean, appears very level, and it looks like there's access on most sides of the building. So the contractor will be able to potentially order these panels according to the elevation. They can stage them as shown here, which will really reduce the amount of equipment needed, the type of equipment needed, and then of course, just the handling time with the labor to install those panels. So upper left-hand corner is really, ideal conditions. And also the height of the building there. That's also important to take into account for, because if there is equipment, it looks like there's plenty of room to move around. Now on the lower right-hand side, which most jobs look like, you can see that there's wet equipment. A normal forklift might not be able to go through that. Also, it looks like IMPs can only be staged in certain areas. So as the contractor's installing the material, they may only be able to bring one bundle of material to the elevation that they're working on. And when they get through those panels, they have to run to another part of the job, maybe on the back side of the building, bring it around front. They don't have a lot of storing areas, a lot of staging areas, and it may be complicated for equipment. Think of, if you were working on a pre-engineered metal building in the middle of Nebraska versus working on a high rise in New York City. Certainly those site conditions are really going to drive the labor and then also the equipment needed and how the materials ordered and how the materials staged. Now we can get into the different types of building complexities. It's important to know, what type of building and how complex it is, because that's really going to determine materials, additional resources, your labor, your equipment that you're going to need, and how you're going to store and install that material on site. So for example here, let's look at building complexity A. Building complexity A, I often refer to as, say, pre-engineered metal buildings. They're typically relatively low in height, square, pretty symmetrical, even and consistent. So we can look at the front elevation here and why the building's a little cut up. There is, multiple garage doors. We have those canopies there that are in front of the IMP and fastened back to the structure. We have to account for that. Each area has a window and then also a man door. But overall, the height of the building, it's not very tall, relatively consistent, so the details will not change. The trim details won't change. The actual trims won't change either. From each unit is pretty consistent there. On this particular building, there's actually a soffit, so there's room for the IMP at the top there. There is a soffit panel that you can't see real well from the elevation. So we can account for, okay, using the equipment, probably won't need a crane, probably just use a lift with some panel suction cup equipment, and you can determine your size of your crew here. Taking a closer look at that building, we can see that it is a pre-engineered metal building. It's relatively open. There's a lot of room inside the building if materials or items need to be stored. And we can see those trim conditions on there as well. The head of the doors, the windows, we can see those jambs and the base trim that's sitting on the block there. We can also get a really good idea of the panel deduction. So when we look at, say, on that very far left-hand side, closest to that first garage door, you can see there's a full-length panel, and then there's 3 panels that are actually deducted, and then that 4th panel on the right-hand side, where it's just, a small cutout, but a full-length panel would be needed. So this is a really good example of being careful with those panel deducts. And then, of course, at the man door and the windows, that panel would be ordered full length and then just field cut. So this is a good example of seeing a category 1 building, relatively simple in design and layout. And here's the finished product. So we can see our garage door locations on the front of the building. We can see some windows and canopies on the side, but on the 2 rear sides of the building, they're just straight panel runs. So very limited amount of trim, some corner trim and some base trim. So relatively straightforward in design. There's no jogs on the building, up and over roof. This would be a great example of a complexity A wall panel project. Now roofs, a complexity A roof. Here's an example where we can see that there's 2, the up and over roof on the main port, which is the clear story, and then we have the lower portions of the roof. The lengths of the roof are relatively short. The height of the building when we get into it is not very tall, so cranes would not be needed for it. Straight panel runs, no valleys on the building. It's a pretty straightforward, ridge, your eaves, your rakes. There is a head detail there with that lower portion of the panels, but really no specialized equipment really would be needed for this. Maybe a panel lifter and the appropriate lifts, but no crane. You can see that there's easy access on the inside of the building if needed. And of course, the finished product on the exterior. You can see standard details on the ridge and the rakes, and also the eave there. And then of course the head wall there underneath that clear story. But the height of the building is relatively straightforward. Also site conditions, you can see that the conditions are relatively open and there's a lot of room to work and move around. Here's other examples of building complexity A. Once again, we're more into that pre-engineered metal building, limited penetrations, limited details, some standard ones, walls, windows, doors, potentially some louvers, but not too many, difficult architectural elements. You can see here, these are all examples of vertical panel installation. Then we get into our building complexity A. So we're taking all those elements from a building complexity A and putting that into building complexity B and adding some additional elements to it. A lot of times when we get into complexity A, the buildings are going to be larger, they're going to be taller, there may be some sidewalls or some jogs on the building. We may be looking at multiple panel profiles. In this example, we're looking at 2 different panel profiles. You can see the building's a lot more cut up. There's a lot more windows or louvers associated with the building there, potentially some different profiles. So now that we're not only looking at height considerations, maybe some site condition considerations, but the details. If we're looking at two different panel profiles, each in its own color, we can count the total trims, but we have to account for the different color trims and the locations of those trims. So we're taking a complexity A building, making it bigger, adding more elements to it, and certainly, with those windows, definitely making the building much more complicated. It's going to be a slower install. So these are all areas that we will have to account for. Also, when you get into complexity B buildings, that could be used where the IMPs are used as a roof and also as ceiling panels, such as we see, say, in cold storage. With cold storage, the vapor and air barriers, that's a major consideration. The detailing is much more stringent, and that's certainly going to add to the complexity of the building. Also, if the building has maybe some additional span requirements, where the panels may need back fastening or additional attachment points, once again, those are other considerations that would really slow down the insulation of the building. You can see some examples here. So we do have in that lower left, that large box, that pre-engineered metal building look, but now we have a mixed use of metals there. We can see the gray IMPs, we have red IMPs, but we can see that angled trim detail, which adds to the complexity. On the blue panels, that's actually an MCM panel. So we're incorporating insulated metal panels with other types of materials or other metal materials. On the upper left-hand corner, you can see that there's some venting or louvering, and then there's architectural bubbles that have to be accounted for and ensure weather tightness. The roof example there, where we have some valleys and movable layers with the insulated metal panel, that adds to the complexity of it. And then, of course, down in the lower right-hand corner, we're integrating vertical insulated metal panels with horizontal insulated metal panels. So that adds to the complexity and the detailing, which require additional considerations when doing the estimating. And then last but not least, our complexity C building. Complexity C is where we're adding all of these different architectural elements. A lot of times we will see moldable profiles, moldable widths, moldable colors, maybe some custom integration of integrated window systems or integrated louver systems, different panel widths. Panel layout is often very important. A lot of times these would be considered our high-end architectural horizontal projects. This example here, we can have horizontal panels with built-in factory-formed corners, factory-formed trimless ends, built-in reveals in the panel interlock along the horizontal portion of it, maybe some custom eyebrows or other architectural elements. I believe this building has some integrated lighting systems in those architectural bands. And then, of course, the other architectural structural elements that are penetrating through the IMP. In this type of project, panel layout is absolutely critical. All of those vertical reveals have to line up perfectly. Everything really has to be measured multiple times before the material is ordered, or panels will have to be refabricated. This is where the building really slows down. We have to account not only for the site conditions, the height of the building, the equipment used, but also the much more complex material list that go along with this type of application. Once again, when we get into the details of the complexity C building, there might be integrated window systems or integrated louver systems. And then, of course, the different panels and profiles on there. Those vertical reveals and horizontal reveals really require a lot of measurement and a lot of key considerations when doing the panel layout. The material lists, like I said, are going to be much more complicated. So instead of maybe dealing with one type of panel, one type of color, and one type of profile in a vertical application, we might have panels that are vertical and horizontal. We might have 2, 3, 4 different profiles in different colors, in different widths, which are all going to add, it's almost like if you had a building with 4 different profiles, it's almost like 4 miniature buildings all built into one. And here's some examples of that. So you can see on the far left here, we're going to have built-in horizontal reveals. We're going to have those factory-formed trimless ends for those vertical reveals, mitered corners on the building. You can see multiple widths and multiple colors, and they're all laid out specifically. You can see in a lot of locations they're lining up with window mullions, which is very important, and then being incorporated with other materials that are on the project. For example, up in the upper right-hand corner, you can see a lot of those panels are lining up with the windows. We have those trimless ends and those factory form corners. And we can see the panels are wrapping around that column area. They're adding an additional architectural element, but really difficulty when it comes to installing and also the estimating portion of it. Panel below, if you get into custom colors, that adds additional complexity and cost associated with the building. And then last but not least, if there's any type of custom curve panels on the building, are they lining up with windows or other type of panels? So you can see how much more time it will take to do an estimate with a complex project, the additional materials and the additional considerations. You can see on most of these sites that there's not as much room. We're not out in the wide open. We'll have to take in consideration, maybe there's some road closures or specialized equipment needed. In summary, we always want to account for any type of waste or details. We want to account for having additional materials and accounting for any type of scrap we might have on the project. We really need to know that project, the labor and the equipment needed, along with the material. Building A's are typically low rise and pre-engineered, straightforward square buildings, not very complicated. A lot of times the site might have open conditions to easily work around and stage the material. When we get into Building B, a lot of times the buildings are getting larger, maybe different panel profiles on there. Building may be more cut up with additional windows and doors. And then last but not least, that building type C, which is very complex. And every detail really needs to be accounted for, making it the most difficult to estimate and then ultimately create the material list for the building. So thank you so much. I certainly appreciate the opportunity to be here. If anyone has any questions, we'd be able to stick around for a couple minutes and see if we can answer them.
Yeah, we do actually have a question in the Q&A section.
Okay.
Thoughts on roof component that can be used as an insulated roof deck in cold weather, R49 plus.
Okay, so would you repeat the question one more time? I just want to make sure I understand.
Yeah, so this individual is looking for your thoughts on a roof component that can be used as an insulated roof deck in cold weather.
Okay, so I'm going to answer it two ways. So roof deck versus a insulated metal roof panel. So a insulated metal roof panel is designed to be just put over open framing. And that's the same with the walls as well. Other underlayments or other type of decking are not required. Insulated metal panels are designed to be used on open framing. And that would include with, say, a standing seam insulated metal roof. It would go directly onto the roof. Spanning capabilities, we see anywhere from 3, 4, 5, 6. A lot of manufacturers test their panels up to 7 foot long. Now, the question roof deck, there is some manufacturers that get into using a insulated metal panel as a deck in like low slope applications, and then put your traditional low slope materials on there. Myself at ATES, we do not get into using insulated panels as a roof deck. That is a engineered system that is available through some manufacturers. Most manufacturers do make insulated metal panels up to 6 inches, but getting up into the higher R values for the application that you're suggesting, I do believe there is some manufacturers that are now making panels for that application up to 8 inches. So insulated metal panels are available as a roof deck application, but I wouldn't be the expert on that because I do not offer it at our company.
Awesome, great answer. Okay, I am not seeing any other questions. So thank you all so much for joining us today. Thank you especially to you, RC, for being here with us. We do look forward to welcoming all of you to our next MetalCon Live. Again, mark your calendars. That's on August 16th and we'll be on rain screens. If you would like to join us at MetalCon in person, the IMP Alliance of the MCA will be doing another session in person in the Architects Experience. We hope to see you all there. And again, a huge thank you to everyone who joined us and a special thank you to RC for presenting today. We hope you all have a great rest of your day and we'll see you soon. Bye, everyone.